I reckon it's probably a good time to start. So I presume a lot of you here are Galera Cluster users, and presumably you are interested in working with Kubernetes as well. And here, that's what we're going to do, and we're going to do demos in between as well to make it extremely convenient. I don't believe it will take a full hour, but I think we should be able to do this in potentially even half an hour to 40 minutes. So thank you for coming, and let's get started. So I've been involved with MariaDB and for a very long time, and before that I was in MySQL, and I've been doing Galera Cluster for also a very long time. So overall, I can say I've had over 20 years of experience in the MySQL database world. So, what is Galera Cluster? Oops. There. So, what is Galera Cluster realistically? Oh, GoToWebinar is being funky today. So, Galera Cluster is really virtually synchronous replication where you have a 3-node minimum. Basically, every node contains a duplicate copy of data in other nodes, so all nodes are equal, and you have pretty good high availability thanks to this. Minor technical difficulties clearly, but yes. Besides that, there is no single point of failure. There is no data loss. It uses quorum-based failure handling, which means there is a voting, which is useful. This is why we recommend a minimum of 3 nodes and not anything less, though there are workarounds for that, because when one node goes away, 2/3 is still around, and 2/3 constitutes a quorum. We use optimistic concurrency control, which ensures that every time you make a transaction, it gets certified on other nodes. Only if the certification is okay does it actually go to the app and say it's okay. Otherwise, it basically has to roll back. So that's another useful thing of Galera. It's got no failover framework required because it's all built in. And it's totally not just optimized for local area network usage. It's fully optimized for cloud and wide area network usage. And I presume for many of you, you are probably already playing with the cloud. Of course, if you just launch, say, AWS in one region, it's basically a local area network. But with Galera, you could launch in 3 regions, and that would be a wide area network. So it's very convenient for you to actually do a setup in, say, San Francisco, Frankfurt, and Singapore, for example. So across multiple continents without any issue. What is Kubernetes overall? And Kubernetes is an open source platform for managing, automating deployment, scaling, and so forth. All your applications across clusters of servers. It handles the orchestration, the automatic scalability, the high availability, can restart failed pods. It's fully portable, and it can also run databases and other stateful services. So Kubernetes is actually quite useful. But without much further ado, I think there's nothing like going to do a little bit of a quick practical here to ensure that we know what's going on. So I'm of course going to spend some time with DigitalOcean here. So got the little Galera training thing happening here. Strangely, it's missing a resource. Anyway, let's hop on over to the terminal where I have a little control agent here. And I put it here in the slides of what I'm going to install. So I'm going to do a snap install kubectl classic. And after I install kubectl, I'll also install Helm. So this is basically what you do to any Kubernetes cluster. Snap is something which is a package manager for Ubuntu in addition to apt and dev. And while we do this, we will also hop on over here to create a Kubernetes cluster. We will naturally launch a 3-node Kubernetes cluster. So pick the Singapore region. And let's go with Galera. Definitely want to have more RAM, so I'm going to go for 8 gigabytes because MySQL itself will require like 4. And you can actually set the node pool to auto scale, so you can have a minimum of 3 nodes and maximum of 5. And you can even change this to 9 if you'd like. And that's pretty much it. Let's call it Galera as well. Make it easy. Easy for typing. So I'll create a cluster. This takes a bit of time. As you can see, it's provisioning, and this is exactly the same as you'd see in Amazon EKS, Google Cloud. It's just different interface. Basically, soon once it's available, I will grab the config file. So it's basically provisioning the node, as you can see. I've already got the kubectl and the Helm installed. So I could actually do mkdir cube. And only when I get the config file can I still provisioning. Did not add any high availability or anything of that sort. Create the cluster ID. So here's what we would do to configure Kubernetes. But as you can see, it's taking a bit of time to provision those nodes. So we'll let it do its thing. Come back here shortly. Then a little bit of a package manager called Helm Charts, right? Basically, that's what Helm is. It's a package manager, simplifies deployment management. It automates the process of deployment, making it easy to install any application like a Galera cluster with a single command. It can handle configuration management, version control. It's fully consistent. I think the biggest claim to fame is it's consistent across environments. So you can have the developer environment, staging environment, production environments are all now basically the same. I think this is actually really useful. So we actually have a bit more work to do here. So let me see if we actually have some updates here. It's still provisioning the nodes. So as I said, this can take some time. Hit the reload button because maybe a bit impatient, but I'm going to guess it's not going to be provisioning. So don't worry, we will come back to run all of this as time goes by. And the whole magic sauce of all of this is actually the fact that we have this Docker images, and we use these Docker images that will help us create, deploy, and run applications in containers. So we basically have a Docker container with the entire MySQL with right-side replication, which is Galera enabled. It's a very minimal installation. Kubernetes will then orchestrate, manage, scale the Docker containers, handle scheduling, the load balancer, and health checks. And Helm Charts really just there for deployment management, which can simplify deploying and maintaining the containerized apps in Kubernetes, basically streamline setup and scaling as well. So that's the general setup. Today, the provisioning, as you can see, we are 2 out of 3 nodes provisioned, which is a good thing. So we just short of 1 added node. So very soon it should be ready. At which point this download the config file will be ready. So we're now at 3 out of 3 nodes. So it's getting close. So firstly, I am going to go to the downloads folder. Of course, I need to make sure I copy it over to the right files. So slow provisioning. So not necessarily the quickest. Also, I don't know if you know about the Docker Hub, but Codeship has Galera Manager, Galera there as well. So if we go to the Docker Hub here, this is actually where we keep stuff. It's asking for login. So still provisioning. So you'll notice that as it provisions, we have 3 node Galera, 3 basic nodes with nothing installed on it yet, but it is a 3 node, 3 pod installation, so to speak. And there will be a load balancer created, and that's possibly what we're also waiting for now. So it's basically still creating a Kubernetes cluster. As I said, taking it. So we've got the 3 nodes, just no load balancer yet. So sadly, there's nothing I can show you here yet because it's still very new. And it's getting there. Also note that Kubernetes can also upgrade, like any day after 6 p.m., for example. So you can actually modify the upgrade windows up to you. You can also run readiness checks when things are operating and so forth. Finally, we have the 3 node Galera cluster running. So you can see that we have 3 nodes here, and you can actually grow to +2. Now I will download the configuration file, which is called Galera kubeconfig. And just for good measure, so we have this to okay, so we've got that there. So we can just mv Galera kubeconfig config. Okay, let's make sure we've modded it. And now if I do kubectl get nodes, I should be able to see, because I have access to this configuration, well, it's a bit of an unbundled error. Connection is refused. Like with all good demos, something might go wrong. First and foremost, so let me just make doubly sure. This looks Good. So, as mentioned, sometimes you do a demo and things just don't work out. This is actually even a very basic configuration file, so this is not even not doing anything weird. So let me do this. So that's rather weird as an error for what it's worth. We don't normally see this. So it's possible there is an issue with Snap. I could try refuse. Did you specify the right host report? Let's try this. Oop. Did I not create? Oh, of course. One minor error. I should have made it .cube. This should hopefully make things work. Voila, so one literal binary error. It's .cube. And once we do that, if I do kubectl get nodes, voila, everything goes as per normal. Akhilesh says that he can't hear anything. Does anybody else have a problem hearing anything? Larissa, can you hear everything? Good?
I can hear you, yes.
Excellent. Okay. Okay. So now that we did that, after a minor snafu, which is of course again no big deal. Let's go back to the Helm charts, which I said we actually put it all up here on GitHub. So we have it under the containers, and we actually even specify here where the release is. So you can just go grab it from here. We have many branches, many tags, and as you can see here, if I click releases, you will find this exact thing here. So if I copy this link address, it should match this. And all I have to do is do a wget, and that's done. Then I go into the MySQL Galera. I'll do a kubectl create namespace Galera. Now I can actually look at the values.yaml. And the reason why I wanted to show this to you is we have, of course, got Docker registry here, CodeShip, MySQL Galera, using 8039 in this case, no username. So the password for the root password, for example, is set me, and the username can also have a username and a password. So I could of course change this to my new pass as an example. And I don't think I'm really bothered about read-only libraries checks at this stage. Then we've got memory 4 gigs, 1 CPU, storage 2 gigs, and we expose the port, and then I just say, I write that. And then we move on to the next thing, which is Helm install. Well, sorry, Akhilesh, other people seem to be able to hear you, hear me. I'm sorry. So not sure why you can't hear me, but maybe you could try calling in directly or something. And okay, so we do a Helm install, Galera release. Yeah, dot dash n Galera. This should take a bit of time, but overall, if I do kubectl get pods, see what's going on. So it's all in the init phase at this stage. So again, I can pop back here to the GUI interface of DigitalOcean. And so we know it's got connectivity. And if I pop down the resources, we know there are 3 machines here. So it looks like we got a pod initializing to running, so that's definitely a good sign. So kubectl get pods. We've got Galera release MySQL Galera 0, 1, 2. So if we do this, so this one's a long one, I think. So maybe I should just do a bit of a copy and paste here. Galera release MySQL Galera 0 is correct. So if you don't put a password, of course, you don't see anything. But if I enter the password, I actually do have a nice 3-node Galera cluster created for me via Kubernetes. I think that's kind of useful. So if I now basically tell it I would like a bash, which I can do. Now if I type MySQL -u root -p, again, I have a 3-node Galera cluster right here. If I do show databases, it's all there, obviously. And if I do kubectl get service Galera, you may notice that I have a little load balancer here as well. So we probably just want to install client library so that I can connect to the load balancer. Frankly, even you can connect to the load balancer. So we do MySQL dash, oh my God, let me figure out. So that was the load balancer IP right there. Okay, it's got an external ID too, which we can also use. So let's go for it. So here's an example. I connected to Galera 2, as you can see here. First, we must get the password correct. And if I do, I'm connected now to Galera 0, as you can see, different server. And if I do that again, I'm connected to Galera 1. I keep on connecting different things based on the load balancer. And again, if we go down to the resources, you will find that you basically get a load balancer created for you here. So we have one load balancer IP, and that's the IP you will pass on to your application basically. And we can do, of course, many other things like maybe get another add there. So yeah, basically everything I showed you. So if I copy this, for example, to execute on the next one, you will see I've connected to a different server. So this is Galera 1, this is Galera 0, and the server UIDs are of course different as well. So I didn't install the DOCTL or anything for that matter. And so everything with regards to how we pass things here is actually configurable here. You can also configure it inside your templates. And here we've got some secrets. So we've got all the stuff here for secrets. SST method is also here. It's all in the template. So while you didn't see the values.yaml, everything is inside the template. So please don't forget to take a look at the templates like regpret even for your credentials and so forth. And in this particular example, we are using SST method, which is clone, because that is the default in MySQL 8. But if we want, we can also go there, and you'll see under services and stateful set. So here again, you can see what we are passing through. We created a load balancer, what ports are required, and we've also and stateful set.yaml is actually a nice long configuration as well of what we're doing. And don't forget that we did all of this in the Docker container as well. So the Docker container is obviously public for anyone to utilize. So as mentioned, we shouldn't take too long. So what are these best practices? Something's really up with GoToWebinar today. Ensure your data is persistent. We use stateful sets to help with stable network IDs, ensure node synchronization. We also think of persistent volume claims, so we never believe in data loss. Even though we set up a 2 GB database, realistically, it makes sense for us to ensure that you don't have any data loss whatsoever. We also have readiness probes, so traffic is in sentinels that aren't synced. And oh, sorry. Every time I click on the go to webinar thing, it goes away. We use liveness probes to detect restart fail nodes. We also, of course, watch CPU memory requirements of the database. So as I said, even though I asked for an 8 GB setup, you'll notice that with said 8 GB setup, uh, of course, naturally, we only use a much smaller variant of it as well. And you should also adjust affinity with Helm to ensure all your pods are created on the same physical server. Really bad idea. Because if they all go away, then there goes your Galera. We also obviously recommend a very fast and reliable network. Uh, Again, if you use things like AWS or Google Cloud or DigitalOcean, any of the managed providers, you're actually getting a fast, reliable network. This is more if you're setting it up locally, make sure you've got all that going. And then, of course, we can obviously monitor the state of a Kubernetes cluster through Galera Manager as well, just by pointing out the IPs it needs to get to. Galera Manager will eventually be able to also deploy your Kubernetes into Kubernetes, but that's not something you can do today. But this is the base work of what you should be able to do soon. So even with all the snafus, I did say that we would be able to finish fairly quickly because that's the whole beauty of having all this just work. And so I see another question here. Need to install on Kubernetes, on local server cloud, how do you provide load balancer IP? So actually we specify here to create the load balancer, right? So we actually have it here. So again, just so you note, DigitalOcean itself does not create load balancer for you here. So if you look here, you see load balancers and volume shown you manage in kubectl. So we actually put it here as well. We spec it here that we want a load balancer with external port and so forth. I'd like to let you know that we do all our testing with Minikube. So we know, so this is where we do all our testing. And it's very useful. It's something that can run locally, and you don't need any cloud. So it's not really bare metal. It is literally localhost. So this is what we use. We have another question. How does Galera handle node failure? Say I need to replace one nodes. What do you do in that situation? What would be the steps? Well, node failure is very, very interesting, obviously. So again, Galera doesn't care if one node goes away. So we have Galera here, and realistically, if I decided to literally zero, if I decided to hit the recycle button, I could totally do that, or I could even delete it as a heads up. So if I hit the recycle button, show status. Oops. It'll soon drop as it degrades, but it'll also recreate. It's the beauty of Galera. So I could actually, so this is happening. Still obviously no insights as to what's going on. You just get to see it. We're back to 2 nodes, and you know what? Fairly shortly, it will recreate as another pod. So if we need to replace one of the nodes, again, the best practice there is to only replace one node at a time, so one pod at a time. If you take away 2 nodes from the cluster, you are going to have issue. you're going to get two nodes to join at the same time, that also can potentially be an issue because both the nodes are going to be in a state called joiner state, and there can only be one donor, so there shouldn't be any kind of race conditions that can make the cluster in a degraded state. So this one's being recycled, and it will recreate over time. So I think the last time you noticed it took about 4 minutes for the whole thing. We've got obviously got, as you can see, PVC persistent volume claims for all the volumes. And so we have 2 out of 3 nodes running, but we sincerely will get the third node back up again, I would say fairly shortly. And another question is, yes, the recording is of course available, and the configuration file is here. All the commands that I actually used are, it turns out, are all in the slides. So you can actually just follow along very easily. What is important about Galera is how to protect the cluster, because DBs have to read and write every time. Yeah, so your database read and write is going to be sent to the load balancer IP, obviously. And again, as I said, if one node goes away, this is not a problem. If 2 nodes go away, it is still not a problem, even though your cluster is actually technically degraded. But if 3 nodes go away, then of course we have a problem. As I said, it takes quite a while for DigitalOcean to do a recycle of nodes. So you see now it's got 2 out of 4 running, because it's actually spinning up another one to ensure high availability, obviously. And it's still 2, so we are running in a degraded mode, but we will soon get back to a 3-node Galera cluster, all automatically thanks to Kubernetes. It's just not instantaneous process, but at this point in time, I can still do create database, EMEA, for example, use EMEA, show databases. All of this all this continues to just work for what it's worth. And this will eventually, as I said, become normal again in a few minutes. So yeah, that's basically it. You can of course try this yourself on any cloud. Many clouds even give you free credits, and you can also try this yourself on your own hardware. As I mentioned, Minikube is a great option. And if you don't want Minikube, and if you have some kind of your own installation, by all means use that. And feel free to contact us. Tell us how you're using it. You can even actually file issues here, and someone actually did, and all will be well. So I guess with that, I really want to say thank you for listening. Um, it's quite a number of you here. I know one of you had trouble hearing the audio, so just wait for an email with regards to the recording as well. So thank you very much for attending. If you have any questions, as always, you can send an email here, or you can also send a question, which I think many of you did already ask questions, thankfully. So yeah, I think that's pretty much it. Thank you very much for your time.